Hello, I'm Jean-Benoît. I will talk about network information system management software that we developed that is called netmagis. So what is netmagis? Netmagis stands for Network Management Information System. It's an open source software under BSD license. Why did we develop netmagis? We are operating a large campus network named the Osiris network. So we have over 1,500 network equipments, 400 subnets, and 200 people in various labs or building managing their internal networks, and we contact them or we interact with them for the network operations reasons. So netmagis is not Osiris specific. It's a tool that can work for any network, large or small. It's a web application, and the main purpose of netmagis is to manage the network information system. So what does that mean? Many things. Essentially, it's a central repository of all objects managed by the network operators. So you have hosts, network addresses, VLANs, network equipments, all that stuff. And netmagis implements operational processes or automates those processes, and it brings you consistency, exhaustivity, automatic documentation, and many different kind of automation. So what can netmagis do for you? Or for us, for the moment. It can manage hosts, so you enter in host names and associate IPv4, IPv6 addresses and other host parameters, and it automatically generates the DNS zones, the DHCP configuration, the email routing configurations. Another important part of netmagis is the topology module. So it mainly handles VLANs and equipments, network equipments, and links between those equipments. So the topology module can generate automatically all your network maps. You can also set a VLAN ID on a port through the web interface, and this works in a multi-vendor environment. So currently, we support the following vendors. So it works with Cisco switches, HP ProCurve switches, and Juniper EX series switches. Another interesting part of netmagis is the integration of the metrology. So that's all things related to measure. So mainly traffic graphs. There is an automatic generation of the RRD databases and the automatic starting of SNMP polling. Then another module, it's called MAC. It can locate a machine on the network by its IP address. And you can delegate all these functions to other people, to those contacts I had just talked about, with an elaborate system of access rights. So we have a fine-grained access control system. So just to give you a taste of what it looks like, this is the host input interface. So you just put a host name, a domain, an address, IP address, MAC address. You can also put a DHCP profile with DHCP parameters. And if you don't know which address is free, okay, in the example I put an IPv6 address, but in the IPv4 world, sometimes you need to know which address is available, so you can do it through a map. So all the red boxes are taken addresses, and all the green boxes are available address. So you just click on it, and it affects this IP address to the host you're just creating. Then the topology module, which has 3 different kind of views: the Ethernet level view, the IP level view, and the equipment view. So this is the Ethernet view. We called it level 2 because it's on the level 2 layer of the OSI model. you just enter a VLAN name or ID, and it displays a map of this VLAN. So the blue rectangles are switches, the gray or red disks are routers, and the triangle is something unknown. So you have the network backbone at the Ethernet level on this map. Then the L3, so the network view, on the IP level, you just enter an address, and you can see the topology of the network. So you have a broadcast domain in green. That's VLANs. That's a VLAN or several VLANs bridged together. You have still have a switch because it has an IP address, the blue one, and the other are routers. And you can click, these maps are interactive. You can click on any elements. For example, if you click on the green thing, you have this Ethernet view, Ethernet level view. Then last view in the topology module is the network equipment view. You just enter an equipment name, and you see the equipment characteristics, what kind of equipment it is, and the different interfaces, which VLAN are configured on these interfaces. So you can click on Edit to modify an interface, and you have this new window that appears. So you just enter a description. You can set a new VLAN for this interface and generate a traffic sensor that will start the SNMP polling and generate the RG graph. You can modify a group of interface if you want to go quicker. If you want to set 40 interface to the same VLAN, you can do it. So this, again, works on Cisco, HP, and Juniper EX network equipments. And this can be delegated to other network or system administrator. So another function accessible from this equipment view is the traffic visualization. You see there is on some interfaces, there is a traffic button. You click on it, or you click on the link, and you see the traffic graphs, and you can navigate and put a specific start and stop time to see the graph at those times. Then last module is the MAC module. You just enter an IP address or MAC address, and it locates the machine on the network. It can tell you for an IP address which MAC address is associated to it, and on which equipment, which port it is. It has been seen. So to sum up, at the heart of the application, we have all the right management, authentication, and authorization. Then the central repository management, where you find all the hosts and networks and VLANs, etc. Then this part, which cares about host management and which generates the DNS, DHCP, and mail routing file. Then the network and equipment management, so that's topology and metrology. And then the MAC address management. So I want to speak about a particular aspect, interesting aspect, I think, about the topology module. It's a configuration-driven automation. This is a model we have. The network administrator connects on the network equipment and modifies the configuration. The modification is detected and downloaded by the topology server. A model of the network is built, integrating this modification. And from this model, we derive the traffic sensors and the SNMP polling to do. And we derive the network maps. So what does this look like exactly? This is where the magic of netmagis is. You just do this simple modification. You add a link number and a sensor number in the interface description. See, there is L23 and M23. So that's a link 23 and metrology sensor 23. Once you commit the configuration, the modification is detected, and it triggers a chain of action. So the configuration is downloaded and parsed syntactically. Out of this analysis, the software matches identical link numbers because the L23 should be on 2 different equipments that are connected. From all this analysis and matching, we build a highly detailed network model and automatically generate traffic sensors, and then starts the SNMP polling starts, and the error database is created. Let's get a little bit deeper in the network model. So obviously, you up to that point, you understood that we have different network equipments connected, linked together, and in the network model, we have those equipments and the links between them. But the model is much more detailed. You have all this level of detail in one equipment. So let's zoom on it. So we have the links, the physical links, the connection, whether fiber or copper. Right behind the blue rectangles are the physical interface. We name them L1, so their name are gigabit 1/1 and gigabit 1/2. Behind those physical interfaces, we have VLANs. So gigabit 1/1 is a tagged interface with 2 VLANs, with 2 tags, the VLAN ID 10 and 20. And the gigabit 1/2 interface is an untagged interface, just having the VLAN 20. Those crossed gray square are bridging instances. So for those 2 different VLANs, 10 and 20, we have different bridging instances. And behind the bridging instances for VLAN 10, there is a disk, a red disk, which is the L3, the network network node with the management IP address in it, which is connected to the VLAN. So this is the level of detail we have in the network model. I didn't represent all the different node types. We have routing instances. We have many different things. So we can represent precisely a router, a bridge, or a bridge router. So how, under the hood, what's behind netmagis? It's mostly written in Tcl, C, and Perl. We use PostgreSQL as a database. We use Apache as a web server, but any web server implementing CGI we do. The topology module is heavily based on a tool named Rancid to collect the configuration and to send comments to the network equipments. For metrology, as I've already said, it's based on the RRD tool. And to install netmagis, currently there is a FreeBSD port, and Debian package is currently in the building, in the making. All the code is on GitHub, on the address you see, and we welcome all contribution to our project. So, as a conclusion, netmagis evolved over many years. It's a mature software. It's stable. We use it in production since 2002. It's packed with a lot of interesting functions. All modules were developed following our operational needs. So network management is something complex, and at a certain scale, manual handling doesn't work. It gives you inconsistencies and malfunctions. So you cannot do it without automation. So you need a tool, and I advise you to choose netmagis. All the information are on our website, netmagis.org.